Let's talk about graphs of logarithmic functions. So I have a set of data points. So we have x going from -3 to 3, and we have the exponential function 2 to the x equals y, or y equals 2 to the x. And then we have the corresponding logarithmic function log base 2 of y equals x. So if x is -3, the exponential function produces 1/8, and of course the log function produces -3 because that's that exponential. I mean, these are all going to be matching up quite a bit. So -2, 2, so -2 is 1/4, -1 is 1/2, and 0 is 1, and so on. But we come down here to the function notation. So f of x equals 2 to the x. And so 2 to the -3 is 1/8, 2 to the -2 is 1/4, as we saw up there, and the rest of that chart there. But down here for the g of x, now we're taking that 1/8. So if the x value is at 1/8, it produces a -3. If the x value is at 1/4, it produces a -2. If the x value is 1/2, it produces -1. If the x value is 1, so log base 2 of 1 is 0. Log base 2 of 2 is 1, because 2 to the 1 is 2. Log base 2 of 4 is 2. Log base 2 of 8 is 3. So if we graph that original exponential function, you get the blue curve. And if we graph the logarithmic function, you get this orange curve. And just want to illustrate how it's reflected across the line y equals x. And so some of those key values, x being 0, so x being 1 was y being 0. In the other curve, it was x being 0 is y being 1. I do want to point out that in this log one, it's never going to actually get to 0 for x. So I'm sorry for being confusing there. But we see, as x gets closer to 0, it becomes more and more negative, -3, versus -2 and -1. So that's how that curve comes out. So characteristics of the graph of the function f of x equals log base b of x for any real number x and the constant b greater than 0, where b is not equal to 1, we can see the following characteristics in the graph of f of x equals log, that should be a base b. Look at that, fixing it. Of x is a 1-to-1 function. Vertical asymptote is x equals 0, as we saw on the graph up here. It's approaching x equals 0, which is the y-axis. Domain is 0 to infinity. The range is -infinity to infinity. So domain, and it doesn't get to 0, but it gets infinitely close up to infinity. And the range goes down forever, it goes up forever, so it's everything. X-intercept at 1, 0, and key point at b, 1, where b is the base. Let's look at that last one. So 2, 1 should have been a point. Oh, it was. Look at that. Hope that's not making people dizzy. Y-intercept, none, because it is getting infinitely close to it, but it never touches it. Increasing if b is greater than 1, and it's decreasing if b is between 0 and 1. So here we have a couple different pictures. This first one on the left here, that b is greater than 1, so we see like the one we saw with the base 2. But here's the base between 0 and 1. It looks like this instead, so it's inverted. And here's just an example of a couple of different ones. So we have the red is the common log, which is log base 10. The orange is log base e, and the blue is log base 2. So how do you graph a logarithmic function of the form f of x equals log base b of x? Draw and label the vertical asymptote x equals 0. Plot the x-intercept at 1, 0. Plot the key point at b1. Draw a smooth curve through the points. State the domain, 0 to infinity, and the range, -infinity to infinity, and the vertical asymptote. So here we have f of x equals log base 5 of x. So state the domain. They just told us what that would be. It's not shifted at all. Our domain is going to be 0 to infinity. Our range is going to be -infinity to infinity. And we'll have a vertical asymptote at x equals 0. So let me go to, what color do I want? So this would be an asymptote here. Okay. Then it told us to plot the x-intercept at 1, 0. So let me go to green. So we have 1, 0. I'm going to plot that there, and then b comma 1. So this has to be a base of 5, so 5 comma 1. And that's what we need to graph. I always make it more complicated on myself. And then it's going to go down like that. That's our asymptote. Probably make it a little bit more curvy. Okay. That's graphing a logarithmic function.